Okay, in this video, what we're going to cover is scientific notation, how to put numbers in scientific notation, and how to take them out of scientific notation. So scientific notation is simply a shortcut to write very large or very small numbers. So the first thing we're going to do, if we have a very large number like this one, 97 million miles, it's a pretty large number. So I'm going to find the significant figures. So I only have two significant figures. I've got a 9 and a 7. And then I'm going to count. Um, well, actually, before I count, I'm going to write my significant figures down here. So I've got my 9, my 7, and I'm going to put a decimal point after the first significant figure. So now I have 9.7. And then I'm going to multiply that number times 10 to a power. So the power, if I multiply, because we're in a base 10 number system, if I multiply 10 to a certain power, if I multiply 9.7 by 10, I've got 97. So that's like shifting the decimal over once. So let's count how many times I would have to shift the decimal over to make this number equivalent. All right, let's count. So 1, 2, 3, 4, 5. Ooh, that one doesn't count. 6, 7, 8 times. Okay, so it would be 9.7 times 10 to the 8th power. These would be equivalent miles. Okay, so that's just a shortcut way to write 97 million would be to write 9.7 times 10 to the 8th power. Okay, so it also works for very small numbers. So I've got a very small number here. So 0.000001721. All right, so same first step. I'm going to find my significant digits. All my leading zeros are not significant, so I'm just going to find my significant digits. I've got a 1, I've got a 7, I've got a 2, and I've got a 1. Let's put the decimal behind the first significant digit. And now I'm going to multiply by 10 again. But since I'm moving the decimal to the right, since I'm making the number smaller, not bigger, to make it equivalent, I'm going to have 10 to the negative power. That's going to move my decimal in a base 10 system to the right. So let's count how many times I would have to move the decimal to the right. So I've got 1, 2, 3, 4, 5, 6 times. So my number will be 1.721 times 10 to the negative 6 power. 3, 5 meters. Okay, now let's figure out how to take numbers out of scientific notation. I've got this number here, 1.21 times 10 to the 9 watts. All right, so that's a lot of watts. And if I wanted to write this out in standard form, or, like a regular number, I would just write my significant figures that are already listed. So 1, 2, 1, and I'd figure out how many times I'd have to move my decimal, 9, and then just basically fill in my number with some non-significant zeros. So I've got to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times, and I'd fill in that with my insignificant. So fill in all those spaces here, and that's in watts. So I've got 3, 3, 1, 2, 3. If I wanted to put my commas in there, and then I've got, let's see, that is billion, 1,210,000,000 watts, are 1.21 gigawatts, if you remember that joke. Okay, last one. How to take a scientific notation number, put it in standard format for a really small number. So I've got 6.11 times 10 to the negative 7 newtons. All right, so same process. Actually, different process. So I'm going to be moving the decimal to the left because I have a negative here. So I'm going to give myself room to put my leading zeros, my insignificant figure zeros, to that side. So I'll write my 6, my 1, and my 1. And then I know I'm moving the decimal 7 times. So 1, 2, 3, 4, 5, 6, 7. And that's where my decimal goes, is right here. So, and then I can fill in all the other spaces with zeros, and I've got 0.0000000611 newtons.